coming up right now is the Space Show.
This is your community radio station, 88.3 Sun FM.
And we've got a progress report on the Artemis II mission, the mission to send astronauts around the moon, 4 of them. Well, as you know, they've had problems, but it looks like they've pretty much got them fixed, and they're going to make a decision probably tomorrow as to when to roll out to the pad. Now, that's a 5-kilometre trip on a crawler transporter. Takes about 6 hours to get out there, and then the rocket will sit on the pad until launch day. At the moment, if they roll out on time, there's a possibility they could launch on Thursday, April the 2nd. Otherwise, they could go the following day, April the 3rd, or Sunday, April the 5th, Monday, April the 6th, Tuesday, April 7, or Wednesday, April 8. If they don't make it by then, they'll have to hold off for several weeks because the moon keeps moving in its orbit. Well, if they do launch on Thursday, April the 2nd, it would be at 9:24 a.m. Australian Eastern Daylight Time. It would be a 2-hour launch window, so the window will open at 9:24, but it could be launched as late as 11:24 on the morning. There's no point telling you more times because, we won't know until then.
Southern FM.
The Bayside.
In 2014, Mike Bolger was the program manager for ground systems development operations at Kennedy Space Center in Florida. In this recording, he was talking about changes to the ground infrastructure at the Kennedy Space Center, which were relevant for both the Artemis program and for commercial programs.
To give you a little more of a terrestrial perspective of what we're doing to get ready for the exploration to Mars, what I wanted to do is tell you some of the work that we've been doing to upgrade our launch infrastructure, our facilities, our ground systems, and our operations processes that we're upgrading to create what we call the 21st century launch complex of the future that we will use as the departure point for our SLS and Orion rocket and spacecraft on our journey to Mars, and also which will support other government commercial users as we go forward. I'm going to talk a lot about flexibility and adaptability because that's really one of the key tenets of our program down here as we've tried to upgrade our systems. We've eliminated the ground systems and the launch pads that were built specifically for the space shuttle. And we're now replacing them with a more streamlined and flexible architecture that will support SLS and Orion and the evolution of the SLS and the Orion as well as other government and commercial launch vehicles. So at Launch Complex 39B, we've removed the shuttle fixed service structure and we're moving towards a clean pad architecture. So that means you won't have the fixed structure that is specific to a launch vehicle and a spacecraft on the pad that will actually roll out as a part of the mobile launcher. That clean pad approach gives us a more flexible, adaptable way of dealing, of again, evolving with SLS and Orion and someday launching other rockets out there as well. We've erected 3 500-foot tall lightning towers out at Pad B. We're implementing a new universal flame deflector and flame trench. We should award that contract this month. And if you drive by there, it's just a beehive of activity with other infrastructure upgrades. We're doing power mods. We're upgrading our environmental control system. We've refurbished our cryospheres. Really just a hub of activity going on out there. Across the street, we've got the iconic vehicle assembly building, 500 feet tall. It's got 4 high bays, each high bay big enough to hold a Statue of Liberty, just to give you a sense of perspective of how big that building is. And inside of there, in high bay 3, we have taken out the old shuttle platforms, the work platforms, and we're in the process of implementing 10 new work platforms. What's neat about the new work platforms is that they can move up and down, so they're adjustable. They can go 10 feet up or 10 feet down, and each has a insert for the platform that conforms to the outer mold line of the launch vehicle or of the spacecraft. And so that, again, allows us to evolve. We can change out those platforms as we move forward. Other projects in the vehicle assembly building, we're taking out the old copper cabling and implementing fiber optics. We're getting a new fire system. We're doing door refurbishment on the big doors on the sides of the VAB. A lot of low voltage power mods, amongst many others. It's a 50-year-old facility, and we're really making sure that it will be pristine as we move forward with new programs. In the Launch Control Center, which is right next to the vehicle assembly building, we've made a lot of changes to our firing rooms. Fire Room 1 is going to be the fire room that we use to process SLS and Orion. We've equipped it with new state-of-the-art computers, a new command and control system. We're in the process of working on the software. We're using an open architecture that will allow us to evolve and support the engineers who will sit in the fire room to do the processing and ultimately the launch countdown and the launch of SLS and Orion. In Fire Room 4, we've moved in a different direction. We're transforming that into a multi-user control room. So what we're doing there is we're setting up a room that will allow future customers or future spaceport users, future 21st century launch complex users to come in, establish their own command and control system. We can actually divide it up into 4 individual quadrants so that we can process more than one rocket at a time at a Fire Room 4. And so again, we're making major changes and setting ourselves up so that we can support many different kinds of rockets. The mobile launcher hub is just north of the vehicle assembly building, 400-foot structure. It's really the primary interface to our SLS and our Orion launch vehicle and spacecraft. We're very busy working on both tower mods and also platform mods, so that you got a platform, you got a tower, and all the ground systems run through umbilical arms to actually touch the launch vehicle and the spacecraft. That mobile launcher was originally designed for a Ares 1X rocket, so we're doing extensive modifications to strengthen it for the bigger, the larger SLS rocket. We're also preparing it for all of the ground systems that will run through that. So those are the structural mods. At the same time we're doing that, we are designing our new ground systems. So these will be the systems that provide the cryos, the purge air, the power, and the data from the ground to the rocket. We're working on the designs of those. We'll begin the fabrication this year, and we'll start outfitting towards the back half of 2015. We're also working on the umbilical arms, so that's the structure that creates that physical interface between the ground and between the rocket. Umbilical arms are being manufactured now. We're starting testing over in our launch equipment test facility, where we test all of our interface points before we actually use them for a launch countdown. Inside the VAB, if you've got a crawler transporter number 2, we're doing extensive mods to that. That's it's like about 130-foot by 120-foot tank-looking structure that we use to roll the stack out from the vehicle assembly building to the pad. It's undergoing 20-year life cycle modifications. It's been in use since the Apollo program. Really cool structure. Kind of reminds me of something you've seen in a Star Wars movie or something like that if you get a chance to see it. We've completed most of our refurbishment projects on that. Again, we've done things with control systems, with roller bearings. We've done structural mods to support the new big rocket. We're right on track. We're going to do mods for what's called the jacking, equalization, and leveling system, which allows us to go up the slope of the launch pad and keep the rocket perfectly vertical. So we're going to be replacing that system in the next year, doing really well, right on track. Kind of big picture to step back. There's lots of other work going on across the center as well. We're developing our concept of operations and so forth. But big picture, the progress is real and it's tangible. And if you're driving around the Kennedy Space Center, you can see it. It's happening. It's happening fast. So we're really excited. It's certainly a major step in our deep space exploration plan to put astronauts on Mars. And we're also recognizing that the first SLS launch is coming out as fast too.
That was Mike Bolger speaking in 2014 about changes to the ground infrastructure at Kennedy Space Center, including Pad 39B, which is being used for the Space Launch System and the Artemis moon missions. Next up, again from 2014, we'll hear from Chris Crumbly, who was the manager for Space Launch Systems, Payload Integration and Evolution at the Marshall Space Flight Center in Huntsville, Alabama. He's going to talk about the status of the Space Launch System.
I appreciate the opportunity to be a part of this panel on the journey to Mars. We're getting ready to witness the next steps in that journey. For the capability that we're building, SLS will be the largest rocket ever built. The thrust of that rocket will be 10% greater than the Saturn V rocket that took our astronauts to the moon. And as we continue to evolve the rocket, it will grow to even 20% greater than that thrust. It will transport astronauts further into space than ever before. first SLS mission, the EM-1 mission, will be 50% taller and deliver twice the mass of the largest rocket that we have today, the Delta IV rocket that's going to launch on Thursday. Wherever our nation wants to go, SLS can take us there. SLS is a unique, long-term investment designed to be used for decades to come, but it's only part of the ambitious human spaceflight program that we have. It includes the International Space Station and commercial crew. The next step is EM-1, and the capability to reach the moon and beyond is being constructed today. We're making steady progress in constructing the first elements, and many will go into test campaigns in the coming year. The boosters, based on the shuttle, but adding a fifth segment. Each of these boosters is going to provide thrust, 3.5 million pounds of thrust apiece, to take the total thrust of the SLS to 8.4 million pounds at liftoff. We're planning on a motor firing in early spring of 2015, and many of the components that will be ready for the EM-1 launch are constructed today. The engine, the RS-25, those engines exist today based on the shuttle main engine with a few enhancements, including a new computer called the engine controller. We're making the enhancement for new inlet pressures and new temperatures for the size of the core stage that's feeding the engine. 16 of those engines are in storage right now at Stennis, and testing will begin in the new year of the RS-25 engine. The core stage, 200 feet long and 27.5 feet in diameter. Qualification and flight hardware is being constructed at the Machute Assembly Facility in New Orleans, Louisiana right now. You see the world's largest friction stir welder being assembled, ready to build components of that core stage. Test facilities are being readied right now at the Stennis Space Center and also at the Marshall Space Flight Center to put it through its paces, both structurally and also on test firings of the engines and core stage together. The other stage and the adapters are being assembled. The Boeing ULA NASA team completed the negotiations recently, and we now have all components for the vehicle under contract, and development is already halfway through. The interim cryogenic propulsion stage is the same stage that you'll be seeing launching the Orion. A few enhancements to attach it to the SLS. We're also building the launch vehicle stage adapter. We're building the spacecraft adapter. We have simulators for that and for the core stage and for the MPCV being constructed today for a test to begin in 2015 to show the structural capability of those components. So SLS, from its inception in 2010, has made it through PDR. We have completed our key decision point C milestone in July. We have been put on a path to complete our CDR coming up later in 15. All this accomplished in just a few short years. Things are being done. Things are being assembled and being put together. SLS is an evolvable design. As our missions increase in complexity and our destinations further, SLS will develop and evolve to meet that challenge. We're looking at multiple cargo payloads as a portfolio of our missions. SLS will be a multi-purpose workhorse for exploration of our solar system. SLS is partnering with academia, industry, and other NASA organizations to improve our affordability and our safety and our performance. Composites for the exploration upper stage. Composite cryogenic tanks. Those are the things that, as we save weight on the upper stage, every pound we save is a pound of payload that we can take to our destination. We're looking at additive manufacturing, 3D printing of metals. How can we analyze those, manufacture those, and inspect those to put those in critical aerospace parts, such as engines? We're looking at those today. We're looking at enhanced cryogenic handling, storage and transport, replacement of toxic fuels for our attitude control systems, electric power storage and power distribution, and advanced manufacturing with lighter, stronger alloys. We're looking at a new upper stage and new boosters for the future, new fairings. The fairing can grow as large as 33 feet by 102 feet. Very large structures, very large capabilities to make it on our journey to Mars. These capabilities are being sized to meet the proving ground today and as we step forward into the journey to Mars. When we add the upper stage, we'll increase our payload capability 50%. When we add the advanced boosters, we'll increase our payload capability 85%. 130 metric tons of capability on this vehicle. But it's not only the mass and the size and the volume that we can take in this vehicle, it's the speed. There is a deep space mission that we're studying right now that we can save 5 years on the transport by flying direct with the SLS. SLS design is designed to be evolvable to a variety of missions and capabilities. We've looked at studies for years on how do we best make our capability and our journey onto Mars. Again and again, our studies have repeatedly led to requirements that can only be met, or most effectively be met, by a large capability Earth-to-orbit vehicle like SLS. We've been studying Mars robotically for over 40 years. SLS is going to enable human exploration of Mars.
And Chris Crumbly speaking in 2014, giving an update on the Space Launch System. Obviously, nothing stays the same for long. So Isaacman, some of you may know, has recently cancelled a lot of the variants that Chris was speaking about there. Space Show will be back in a couple of minutes.
Southern FM.
Sounds of the Bayside.
And this is the Space Show. Hello, I'm Andrew Rennie. On the Space Show, Stools in Space. To give you an idea of where we're going with this, let us introduce Ookla the Mock. This is a story about the search for the room you never have seen in any of the episodes of the television series Star Trek. This is the comforts of home. I have attended dozens of talks by astronauts. There is one question that invariably gets asked, usually by a child. Walter Cunningham flew the Apollo 7 12 mission 50 years ago, and from that day until he died in January of this year, January of last year, I should say, was asked the same question. The best answer I have ever heard was a curt, very carefully. The most detailed answer I've ever heard was this one by Walter Cunningham.
Our first order of business on waking up, naturally, was to play past the urine bag, technically the UCD, or urine collection device. After it was filled, a series of valves permitted us to dump the contents of the bag overboard. Now that was something worth taking a picture of. If one dumped just at sunset, the flecks of ice coming off the urine dump nozzle would look like a million stars, and it would be impossible to take star sightings for about 5 minutes. Of course, it's a real experience to see your own urine take on a cosmic quality in space. But it is eye-catching, and every crew has taken pictures of it. The ice particles are quite beautiful, the very phenomenon that caused John Glenn to rave about the fireflies at sunset. It was considered a mystery at the time of the first reports, and I don't think space officials ever released a clear explanation. Believe me, just doing it was no simple process. A modified condom was attached to one's penis, and the storage bag was filled through a valving system. After the bag was dumped overboard, we allowed it to drain for a while to ensure all the moisture was out of the system. We were forever forgetting to close the overboard dump valve, and it would eventually bleed down the pressure in the spacecraft enough to trigger an alarm, indicating an air leak. After several days' use, this alarm came to mean simply that the last one at the John had left the urine dump valve open. When time was short, it was possible to urinate straight through the system. With a perfect vacuum at one end of the hose and an essential part of one's anatomy on the other, we tended to be a mite careful in manipulating the valves. Here is probably as good a place as any to answer the other half of the second or third most popular space question. It was the solid waste management problem that we all dreaded. Before Apollo, most missions were less than 4 days in duration, and it was possible to go on a low residue diet and avoid the problem entirely. On Apollo 7, we made it to the third day before anyone had to answer the call of nature. Following my first experience, I wrote the following memo in my logbook to help follow-on crews prepare for their maiden voyage. Use of waste management bags. Clear out as much room as possible in the lower equipment bay and reserve at least 45 minutes. The key to this exercise is setting everything up prior to commencing the main event. The rear door in your long johns is too small to allow a good placement of the bag. I suggest dropping your drawers and getting comfortable. This means disconnecting the med harness. I have done it both ways, and the latter is best. Separate the outer bag and stick it to the wall. It will be used to hold all the little pieces of paper that collect. Lay out at least 4 folded paper towels and the wet wipe that comes with the bag. These paper towels will be used, folded, and used again. One of the towels and the wet wipe, which always seems to be dry. These should be placed within easy reach. Remove the chemical biocide packet and place in the bottom of the bag. Stick the bag to the appropriate spot on your rear as accurately as possible. Try to keep the one-finger glove out of the way. Now attach the urine collection device to the other end, and you're ready to go. Pardon the pun. Use the finger of the bag to push and hold everything to the bottom of the bag. Leave the bag stuck where it is while you clean up the urine portion of the job. Unless you have been singularly unfortunate, you should be able to safely remove the bag from your posterior and attach it by one corner to the couch. Use a couple of the dry towels judiciously and shove them carefully into the bag. Next, apply the wet paper towels and more dry ones as necessary. Finish with a small wet wipe and close the top of the bag, except for a small hole. Break the chemical container at the bottom and mix well, trying not to let too much of the chemical get soaked up by the paper. Knead the bag until well mixed, or as long as you can stand it, and hold it up tightly, forcing the air out of the hole you have left at the top. Place this in the outer bag with all the little pieces that have accumulated. Remove the inner seal cover, seal it, and roll up the outer bag. Remove the protector on the outer sealer, roll the outer bag, and store it in the fecal storage compartment. Good luck. There's more than one thing a fecal bag could be used for. Along about our 4th day in orbit, I encountered a bag of chocolate pudding that had failed at the seams. In attempting to eat the pudding, it was getting squeezed out at several places along the edge. That was an impossible problem in zero gravity, and Wally suggested a fecal bag as the perfect solution where it wouldn't smell or possibly explode as it decomposed. All used fecal bags were sealed tightly and stored in a special compartment that could be vented to the outside to remove disagreeable odors. By the end of the mission, we had 13 little nuggets stored in the compartment, and we didn't give them another thought until the day after splashdown. On that morning, the 3 of us climbed aboard an airplane for a 2-hour flight from the carrier to Cape Kennedy. The only cargo besides the flight crew on this special mission was a large plastic bag containing those 13 nuggets for early delivery to the doctors back on the beach. Depending on the individual scientist, it was debatable which part of the cargo the doctors were more interested in. That plastic bag would capture our own attention 3 days later.
And Apollo 7 astronaut Walter Cunningham has this follow-up anecdote.
The serious work of debriefing was interrupted by one humorous incident. While engineers were analyzing systems, Rita Rapp, the nutritionist, was analyzing each of the empty food bags to determine exactly how many calories each man had consumed on the flight. That was going to be a little tough, since a fair amount of horse trading went on after the 4th day in order to maintain our interest in eating and to minimize our weight loss. Rita was a shy little woman in her 40s, very prim and proper. After 3 days of weighing and measuring, she finally gave up and called us pleading. "Okay, I give up. Where is that last food bag I'm missing?" None of us knew what she was talking about until it was identified as chocolate pudding. The one leaking package, wrapped in a fecal storage bag, could be pictured now lost among the 13 others that had been used for their originally intended purpose. When we told Rita the bad news that it could be found with the boys analyzing the other end of the food chain, she gave a small groan. We didn't hear for several days. Finally, Rita called to say she had located the lost pudding in the last of the 13 bags, which she had carefully unwrapped in pursuit of her data. If that isn't dedication, I don't know what is.
Jim Lovell spent 14 days with Frank Borman on the Gemini 7 mission. How long did Borman last before pooping?
Can you give me some idea how you spend 14 days in that little cramped quarters with somebody else without going absolutely mad?
It's not easy, but you have to remember that you work so long. I was there 3 years for spaceflight, so I'd go up with just about anybody. And Frank and I were, just this close together. And you get to know each other quite well.
Yes.
I mean, it was it was something. As a matter of fact, Frank went, I think, 9 days without having to go to the bathroom.
9 days?
And he said, Jim, this is it. I said, Frank, you only have 5 more days left to go here.
And now to Richard Scheuring. He's a doctor, NASA flight surgeon, and he described the waste management in Apollo.
Very interesting when we turn towards the environmental impacts. This probably had some of the most lively discussion from the Apollo crew, and it was built in part by the research that I did when I would go through the logs and see how often they commented about the encumbrances of the waste management system, specifically the device that collected urine from these male crew members sometimes leaked. And then the fact that they didn't actually have a toilet in Apollo, actually had to use a bag, which I'll talk about more. The importance of having basic human capabilities, the ability to squat, the ability to control odor, and the ability to suck things away from your body. I mean, it sounds kind of disgusting, but I think we're really taking for granted because of, again, mass, power, volume, size, saving, not having a toilet versus a bag seemed to make a lot of sense to engineering. But this particular area came up time and time again with the engineering teams, with the future vehicles, about saving space, saving weight, by just going back to this Apollo system. And I can tell you, if you take nothing else from this briefing, it didn't work. It did not work. Some of the Apollo astronauts years later said, oh, it wasn't that bad a system. I have their live transcript recordings of how bad the system was. John Yenz said it was the bane of the Apollo missions. The crews would intentionally use medication to cause constipation to prevent them from having to use the waste management system because it was so onerous, and they had no way to control odor. So I think enough of it explained, you get the idea, but it affected their appetite. It affected a lot of things that they did. If you're going to talk about improving crew health and performance, having a toilet, having a waste management system that actually takes care of basic human functions is very, very important. Do not take that for granted. Even if they're short duration missions, everyone's got to poop and pee at some point. Enough said. As far as the potable water system, back then they used chlorine, basically bleach, in the water systems, but because of an inability to really mix the water systems very good, they would often get a mouthful of chlorine tainted water, and this affected their ability to really drink a lot of water because it just tasted awful. They would mix in Tang, and they would have chlorine flavored Tang or a bleach flavored orange drink or something like that. We've got a much better way of purifying our systems today. So again, this system has not been an issue, but again, water is a necessary human consumable. You've got to have it. So you've got to ensure that it's not contaminated, that it tastes good, et cetera, et cetera. I've got a picture here. This is actually the urine collection device. It was basically a condom catheter that when you needed to use it, you'd slip your parts in, you would fill the bag up, and then you would attach it to a device, and as you would coordinate with suction, would draw the urine out of the vehicle and expel it into space. Now we have collection bags, and we actually reclaim our urine into a water reclamation system to have our potable water from our urine. This was the Apollo bag. So this was the bag that if you could figure out where your bottom was at, that you would try to coordinate fixing the top of that aperture to your butt and then bear down and try to poop in it and hope the poop actually went into that bag. And oftentimes it didn't. Again, use your imagination. Enough said. Toilets are good.
That was NASA flight surgeon Dr. Richard Scheuring describing this. Now,
Southern FM.
Sound the Bayside.
you listen to The Space Show, which is presented by members of the Space Association of Australia. And our special feature on tonight's Space Show is Stools in Space. Now, Wally Funk was an American aviator who was a member of a group of women tested at the Lovell Clinic for, and they did it in the same way as the candidates for the Mercury Man in Space project. These women later came to be known as the Mercury 13. In giving an oral history, Wally recounted a misunderstanding she had about the dual meaning of one particular word.
They had given me two little white cups. They had said, this is for urine and this is a stool. So I take it back to my motel. Okay, don't know what that is. I did the urine. About 3 days later, the nurse came up and said, Wally, you haven't given us another stool. I said, I don't know what that is. A stool for me was when I was sitting on a stool milking cows as a kid. And then she explained. I said, you don't want that, do you? I said, he said, yes, we can tell a lot about that. So I did that the next day. They all got a big kick out of it because I thought it was a stool that you sat on. Okay. Well, I learned a lot.
And Funk did make it into space courtesy of Jeff Bezos on the New Shepard mission a few years ago now. Well, David Munns is at John Jay College, which is at City University of New York. And he has an excremental history of the space age.
I'm going to be talking a lot about shit. Okay. An excremental history of the space age is argued one that to achieve life among the stars always ironically meant serving the down-to-earth problems of waste management. I want to show how bodily wastes, urine, feces, sweat, became understood and deployed as nutrients in the attempts to build the first space stations, interplanetary spaceships, and ultimately the proposals for lunar and Martian colonies, of which we are hearing a lot about today. It's all very exciting. For decades, Soviet scientists and engineers, as much as their American counterparts, ambitiously dreamed that if sanitary systems could be perfected to return fully waste products as food, water, and air, that, quote, humanity could truly and biologically tear ourselves away from the Earth's biosphere. They discovered what now remains still the purview of science fiction, really. Everything is different in a closed system, as Tim Stanley Robinson tells us. Trumpeted as the solution to live in space has been America's modern food industry that famously dehydrated and placed food into tubes for the astronauts to consume and made the world a tank. Yet to space biologists, food intake was only half the problem. The other half involved waste output. The larger real problem of the closure of material and energy loops in the system. Thus unexpectedly, for space and environmental historians, waste management became the subject of well-funded science and engineering projects in the late 1950s and throughout the 1960s, both within NASA for its military-industrial complexes and, of course, the parallel Soviet program during the space race. Almost certainly, the Soviet program is much larger, much more interesting, and much more opaque, and no one can figure out how to even get in the archive, but I leave that as a challenge to other people. We had a brief chapter on the Soviet program, but it requires just an unbelievable more amount of work. One day, someone will do that. The major technological and scientific challenge of the space age was to close the loop to return waste as air, food, and water, which of course proved to be as much a social and cultural challenge as an engineering one. Now all but forgotten. Decades of work by space scientists and engineers, sanitary engineers, plant physiologists, and nutritionists all struggled to master even one elementary cycle using humans and algae to feed the others air and nutrients. Algae were ready-made solutions to waste management. both on Earth and in space, because algae digested one of the products excreted by humans, namely CO2, but also then itself conveniently excreted O2. And perhaps even the algae growth itself could be consumed as protein and carbohydrates. Algae form the heart of new inventions like the algatron and the recyclostat that their inventors hoped would sustain humanity in space. In engineering and techno-ecological systems to live in space, American and Soviet life science engineers appreciated as early as the 1960s that there is no waste in a closed environment, only nutrients beginning their next journeys through cycles. So this really questions what people are meaning as waste and nutrient. There is no such thing as pollution in a closed system. It's just something else that we're having to live with. Planning their planet ships, as the evocative Soviet label for an interplanetary spacecraft said, to travel into orbit the moon, one day to Mars, the Soviets understood that the space vehicle as a whole was a miniature ecosystem. Even more than the Americans, the Soviets moved towards integrating their cosmonauts into bioregenerative cybernetic systems. They had German Titov, the second time he's been mentioned in this conference, explained, because, quote, no spaceman truly leaves the Earth. He must carry vital portions of it with him. Ideas about the future space station, Mars colonies, generation ships traveling to exoplanet 1 were already postmodern. They did not solely privilege humans, but sought to interconnect plants, animals, and environments into cybernetic techno-like support networks. While the first and single occupant of the Soviet BIOS-1 experiment stayed inside for only a few days, later BIOS-2 and 3 experiments starting in 1972 would see cosmonaut volunteers, both male and female, stay for months or even a full year in the most extreme example, locked inside a closed environment, feeding off their own wastes. As they built their first space station, Skylab and planned the second, Freedom. Only the Americans could name it Freedom. The Americans labored to catch up. Yet, only now in the International Space Station is anything like living in space slowly becoming a reality, nearly 60 years after it was first considered a necessity. The space age revealed a new awareness of environments, not via saving charismatic megafauna like old forests or, Homo sapiens, but through wastes, through disease, through shit, through germs. My favorite exemplar was presented to NASA in April of 1966. It came from William Oswald and Clarence Goliker of the Sanitary Engineering Department of the University of California, Berkeley. Culmination of about 8 years' work, the device was called the Algatron, and it used living algae to recycle human waste back as water and air. It seemed impossible to Oswald that any space program could send anyone to the moon or Mars without a proper waste recovery system. Pointedly, he specifically criticized NASA for adopting the, quote, startling do-it-yourself processes as the handling of feces with a specially constructed glove, which is, of course, precisely what every Gemini and Apollo astronaut did, and a couple of space shuttle missions as well when the toilet broke down. The essential problem was that the human component of the closed system consumed energy and produced all manner of waste. In addition to solid feces, the pair noted, humans excrete liquids including urine, perspiration, skin oils, nasal mucus, sputum, saliva, tears, and semen. This is the eventual fecal bag from Apollo 11 and the really 1960s faux golf pant demonstration model that no one knows who it is, evidently. No one knows who the person is demonstrating the fecal bag, one of the great NASA mysteries. And of course, this is the actual thing on display at the Air and Space Museum, one of the most requested exhibitions. One aspect of an excremental history of the space age has been astronauts bravely facing their own waste. Again, we're talking about gender dynamics, and this is where that comes in. Astronauts have regaled audiences for years with stories about defecation in space, consciously playing with the notion that this, more than anything else, demythologizes the entire endeavor. It really brings it down to earth when you have to shit in space. Speaking at the end of a day of interviews in 1976 with Peter Warshall of the Whole Earth Catalog, Rusty Swikert described how, quote, in Apollo, for feces, you just stack the plastic bag on your butt, and then you go ahead and take a crap. And I can't do Swikert's accent. And then to peel off, the problem is to peel off the bag and make sure that everything stays within the bag, and then get all wiped off. It's basically a 1-hour procedure. And when you look up Apollo mission logs, there are these 1-hour blank blocks, which is where they were taking a crap, which was erased in the official thing because you don't want to talk about that kind of thing. This is also 1976 is the first time anyone had actually basically asked, everyone asked the question, this is the first time anyone had given a real answer in a public forum. This is where it was made sort of public for the first time. Beyond these Boise mentions, however, the topic of space sanitation generally does not find its way into academic, who don't like talking about this kind of thing either, or popular descriptions of space journeys, but is really relegated to books aimed for children, for whom it remains, every single astronaut tells us, the first question that every astronaut gets asked. Okay? There is an enormous disjuncture between the way we as academics and adults talk about this stuff and the way in which the Boise astronauts and children talk about this stuff. It's not really their problem, it's really our problem. They show that, and indeed, the fundamental truth about life among the stars is that the space toilet remains quite literally, quote, the most important piece of equipment to master, as astronaut Scott Kelly said when he arrived at the International Space Station for his full year in 2015. Everything else is secondary. Okay. Oswald and Gulicker understood the Algatron because, of course, then it went larger still. So this is now the third vision of the Saturn V rocket. I guess we'll be seeing a lot at this conference. The Algatron was a miniature version of the grand-scale terrestrial system. The Algatron system itself, counter-rotating drums, was supposed to go in here. This is where it was going to go. This, you might see, these are two white mice. They're living on their own exploration and feces, which are dropping down into the algae system, which then is regenerating air up. They lived for about 200 days. This is a cooling system at the top. The Algatron was a miniature version of the grand-scale terrestrial ecological system of which we are a part, he said, in that the basic principles of the two systems are really the same, only the size and variety of their constituents matter. Their system was aimed at consciously creating as an analog the interrelated existence of all life on Earth. And then subsequently, Boeing also developed this system. These are the Boeing fecal tanks, which the Boeing director had, no one quite knows, could be his wife, could just be the girlfriend, could be somebody, baked into algae cupcakes. So his own feces are being baked into algae cupcakes, which are being regenerated back into the things. At graduation ceremonies at Berkeley, I am reliably informed, Oswald would hand out baked cupcakes to his new graduate students, and there would be little pieces of corn. And when the graduate student commented on it, he would say, "Oh, that must just be from the last journey through." Yeah. Gotta love sanitary engineers. And then there was a McDonnell Douglas. This was 1971. This was the 90-day space simulator. This actually succeeded. It had a actually had a nuclear power source, but the astronaut crew lived inside for 90 days perfectly, happily, no major problems of anything, and they used recycled waste, and then the whole thing was shut down and promptly forgotten, basically forever. Thank you very much.
And that was David Munns from John Jay College, the City University of New York, with that excremental history of the space age, answering the question you probably always wondered about. And a big thank you to Wally Funk and to Richard Scheuring, NASA flight surgeon, and of course to Walter Cunningham. So I'm Andrew Rennie. Big thank you to Richard, and this is The Space Show.